All right, well, welcome everybody on this Friday afternoon. We are excited to be here with you. Well, I should say be with you virtually. Hannah and I, of course, are at the Fairbanks Museum and Planetarium, but we're excited to partner with the Girl Scouts of the Green and White Mountains on this, our final fourth class of 4 for the juniors for your Space Science Investigator Badge. Just a reminder that you can ask questions anytime during today's class. We'll definitely try to hold some for the end as well. Just do so in the Facebook chat on the Girl Scouts Facebook page, and make sure you include your name, just your first name, and wherever you're from, just so we have an indication of who's asking. And without further ado, I'll turn things over now to our excellent presenter, Hannah Buckner.
Thank you, Drew. Ladies, welcome back. I'm very excited to be doing the final class with you guys on the Space Science Investigator Badge. I hope this has been a really informative and interesting and fun thing for you to be working towards, and learning more about yourselves as scientists and learning about astronomy, and just getting to learn about things that are in space, and getting to learn a little bit more about these topics. And so I thought we could start off as usual as reviewing what we talked about in the last class. Let me just pull it up so that I can make sure I'm talking about the right thing. So we were discussing constellations and their stars. Actually, it's ironic because we just talked about that with the brownies. So in this class, you were learning about the constellations. Well, not learning about them, but being able to describe more in detail about the constellations that you see in the night sky, and learning some tricks of the trade to be able to recognize some patterns and significant stars. So if you're out hiking or something at night and you get lost, you can know where you are and figure out how to get back. And then for your materials and your homework, you either had to do a constellation scavenger hunt and look for specific items on the assignment, or you could tell a story through the stars based on the night sky. So and then you either had to write a report, make a PowerPoint, or poster about the constellation. And I hope that was really informative and something really fun to learn about, so that you could have that kind of story in the back pocket that are fun to tell at family gatherings, or when you're going camping, because they are some really interesting and important mythologies that have been passed down since the ancient Greeks. Even before that, but we just didn't talk about the other cultural constellations that there are. So today we are talking about technology. Technology is a really big part of not just our lives, but also a part of science. Technology isn't just like electronics or things that make things better, but in fact, the wheel is technology, and that developed into other things, and it improved, became better, and we learned a lot more about ourselves as creators and engineers. So let me just share this presentation with you so you can see it. And yeah, so we're talking about technology and astronomy, but we'll also be touching on technology and science in general, because the impacts from technology in astronomy and physics actually have applications in many different things. You'll actually see things like, what's it called? Sorry, Drew, I need you to answer this for me. What is the sticky stuff that like you put it together and you pull it apart and you can like use that for like shoes and what is that?
You mean resin? I'm not sure which
No,
thing you're
it's
referring
like they're like hooks and they stick together, and then you can like use them to like put
to.
your
Oh,
like,
Velcros?
Velcro.
Yep.
Velcro was invented because it was used for astronauts, and so that was a technology that was developed. So technology can be smart and dumb. That really just means whether or not it's complex or it's really rather simple. So why do we need technology? Well, we talked about how it can help us in every aspect of the of our lives. And so it allows us to be able to study the planet that we live on, as well as the universe that we exist in, through different ways that we may not necessarily be easily able to do. So we can use technology to help us get faster somewhere, or to see if there are solar winds coming that may disrupt our satellite connections that help us connect with others around the world, or have internet problems. You can also see if there's asteroids coming, or some things that are happening very far away, or learn about the beginning of our universe. So technology is one of the most important aspects of science, besides creative thinking and inventing. So there we go. Okay. So who makes technology? So technology can really be made by anybody, but in the field of astronomy and physics, you generally see that it's engineers and physicists who are making these things that are so innovative or new. So engineering and physics are very similar to each other, but they also have their differences. So when actually you're studying for one of those in college, you can take both, but you'll tend to take more of a certain topic in college. So I didn't take any engineering classes. I took only physics classes, but I have friends who are going into into engineering. So they took physics classes at our university, and then also took engineering classes at another university. And they coincide a lot. So engineers are those who have studied engineering and are applying those in professional ways, or non-professional ways. You can be an engineer and do things for fun. They invent, design, analyze, build and test machines. They build complex systems, structures, gadgets, and materials that really can meet the needs of the world around them. And so it can be the state of cars, or cell phones. The fact that we have computers, that we can do classes online, is a technology that is very useful. But these were actually formed first because of science. But they were found to be useful for everybody. So then they became public commodities, or things that they can use and buy. Engineers really can form the link between the scientific discoveries that have been made, and then applying them to human and business needs, as well as the quality of life. And so our quality of life is increased because of the fact that, ooh, I can shorten my chair. That's increasing my quality of life. I can make myself more comfortable by changing the height of my chair, but also just being able to talk with you simply through the internet and my laptop to teach you about technology and science, and help you get further in your Girl Scouts life and be able to impact those around you. And so it's not just that engineers work on science, but they can work on mathematics, they can work in government, they can work with math and do statistics and things with finance and business. So it's really super applicable. Physics is kind of the same way. You also have tons of applications of the job and the skill sets that you get. But physicists are specifically scientists who can specialize in the field of physics. That includes optics, optical physicists, astrophysicists, astronomers, astrobiologists. Chemistry involves physics, and physics is that encompassing the interactions of matter and energy at all length and time scales in the physical universe. So that can include light, energy, sound. Well, sound is energy. But also looking at lengths of things, and you can use physics in looking at whether or not the earthquakes that we are experiencing are big or not, and how they compare to Mars quakes or Venus quakes. So these, both of these types of people, or the jobs that they do, really can invent and make new technologies that make it easier to do their jobs, or discover new things about doing their jobs that may make it more successful, or learning about how to figure out things about the universe by inventing new things to be able to study that. So one of the things that we have seen being made are telescopes. This has been around since Galileo, actually before Galileo, but now we've gotten to the point where we have these new ways of looking at stars and energy that they're giving off, things in the electromagnetic radiation spectrum, which is just light, things that are moving as waves. So it may not look like it, but this thing that you're actually seeing on the right is the James Webb Space Telescope. And it's covered in gold, and it's massive. It's also about $3 trillion over budget, just because it is quite big and there's a lot going into it. But once we put it into space, it's actually going to be a lot more powerful than the Hubble telescope, which we've seen so many wonderful pictures from that, including the Deep Space Array image that is very famous. But these telescopes that are built both on Earth and space are built to observe the universe around us at all light wavelengths. So that includes radio, microwave, X-rays, gamma rays, visible light, which means light that we can see, UV red light, which is ultraviolet, and infrared, or IR. And we've learned to make them bigger, more clear. We've used adaptive optics that have been discovered by engineers and physicists to increase, but we've been learning about optics and using optics to learn more about the world around us. We also have developed a way of using telescopes to basically turn Earth into a giant telescope. So a telescope doesn't just use lenses to bring light in from the front of the telescope and turn it to an eyepiece. A lot of telescopes now are computer-based, so they take data that is coming in, being put onto these like smart surfaces, kind of like a smartphone face, or the solar panels that use, I won't really talk about that because that can be kind of confusing, but it uses energy in a specific way to convert light into energy, into electricity. So that can be applicable in this. And so when you have telescopes on either side of the Earth's radius or diameter, diameter, which is the whole like separation of Earth in half, essentially you've taken all of these telescopes that can see one half of the Earth, the other one can see the other half. It's turning into binocular vision. So instead of having one eye seeing over here, one eye seeing over here, you now have this whole vision. And so you've turned the Earth into a giant telescope. And so now you can gather even more information and data at one time. And that's very useful. This never would have been thought before, but we've learned from adapting the discoveries that have been made. Technology has allowed us to be able to do that. And that's actually how we were able to discover the first picture, we were able to take the first picture of a black hole. And that was the first time we were ever able to do that. And we've made these strides in physics and astronomy because of developing the technology that we have. The fact that we have space-based telescopes is fantastic. For a long time, we're not able to get clear pictures because we were having atmospheric interference, we were having solar radiation interference, things that were coming in that were just messing up with the light. But now that we have space telescopes, they can use different wavelengths of light to be able to clear out things and to take care of interference of light and just like particles. And we now have really clear images of things that we never would have been able to see before, or taken data points of amplitudes of light, which it means like how bright something is, studying the energy of things. The fact that we have these telescopes have just made it so much easier to do our jobs and to study the universe around us. We also have robots. which they have been so important in the growth of our society, not just in science, but we have like robots in our phones. We now have AI, which is insane. Robots come from coding, so you put in a code into the system and you build the parts for it and they work together to help us. And so this picture that you're actually seeing on the left is called Astrobee. It is a hands-free robot system that provides a research platform to astronauts working on the International Space Station to be able to do work in an easier way and not have to like hold it or move a lot in it. They can just like put stuff in and run simulations and tests on the platform. And so it is really useful for them. But robots have helped us with drones, with the robots that we've put on Mars and Venus. We've had things going around our atmosphere to test certain things, or we've used robots to practice trying to get around on different environments, which have been helpful for those training to go to Mars or the moon. Yeah, they've been really good, and we've been able to apply these to civilian life and commercially, where we're using robots now to deliver goods or to help people in stores, or to help run tests to make sure we don't spread contagion. Or we're actually seeing now too that people are able to give samples to robots in certain places and using that as a way to get vaccines. And so that's actually quite helpful now because we are doing social distancing. And so if it means that you can separate yourself between a doctor and the other patients, you're going to be you're going to have a less risk of developing something or catching the coronavirus because you're removing these things. So robots are so applicable and they help us learn about so many different things. And the fact that we've developed this is so fantastic because using robots to go to other places means that we can study places like Mars or Titan, which is a moon, and we probably won't be able to go there for about another 100 years. Well, Mars is much sooner than that, but engineers and physicists developing these things have made it so much easier to be able to learn more about what's around us and to bring samples back. So robots are really, really important in our world, and coding has become the background of science. As a physicist, you have to know, or you have to learn how to code. I myself don't know how to code in Python, but it's a goal of mine to learn how to code with Python because that is something that a lot of physicists use. We had to learn how to code with C++ as an undergraduate student. Different places ask you to learn different codes, and those are important and essential with robots and writing code for telescopes and simulations for things. So this technology has been so important to us. And it also goes into spacecraft and rockets. So we mainly see this on the front line of science, especially with astronomy. Spacecraft and rockets are useful in different ways. They can bring things to space, they can return things, but it can also carry people and keep them in orbit. So spacecraft and rockets can be useful to get fuel, astronauts, scientific materials, satellites, and robots up into space, either to get to the International Space Station or launch a satellite into orbit, or even take a robot to another planet or moon, like the robots on Mars, or to bring a satellite like Cassini to, was it Saturn? Yes, this is Cassini to Saturn. And then Juno to Jupiter. No, Juno. Doesn't matter. So, we keep developing these and making it better and safer. We know that there have been some spacecraft that have unfortunately exploded and taken some lives of American heroes and other people from around the world who were giving their lives to science to be able to study more about our planet and our universe. And so we've developed safer spacecraft, and we're trying to actually there's a project right now that is trying to find non-toxic but also really efficient rocket fuel that can take people into space and work longer and better and not have as much danger of catching oxygen and combusting and then imploding on itself. But rockets also can bring goods up to International Space Station, or again, launch satellites into space. You know, we have to get them out of the atmosphere and fight the gravity of Earth here on the surface. And so they've been really essential for that as well. There's a hope for one day bringing civilians into space commercially, so that, you know, there might be a space hotel, or having a halfway point between Earth and Mars. And so using the moon or another space station as a transfer point so that you can be more efficient with that. So the fact that we have these is important. Well, they're all important, but this is what has allowed us to get into space. This is also how we've launched our telescopes into space, getting our astronauts and our robots into space as well. So these are essential, really, for being able to get beyond our own world. Are you moving? Okay. Satellites. Oh, satellites. They're very important. We were using satellites for government purposes in doing research, but we found that they were able to reflect and carry connections. And so satellites for the longest time were actually used for connecting TV. Satellites also get us phone connection, internet connection, and they can also measure weather, storms that are around, seeing heat. So a lot of things that we are seeing with like the weather reports are a mixture of weather planes and satellites. We need them for our day-to-day needs, as well as the scientific community, because they can study things like solar flares or wind patterns, or things that are going on with like algae, which is important for us, because if you live near a place that can have an algae bloom, that can be disastrous for that community, because it can create sickness in food, or death if someone goes swimming in that. It can also create land problems. So like satellites have many applications, and these were developed by engineers and physicists. And so we're seeing a trend here, or a pattern, that things that are developed for science and really for astronomy to have tons of applications in commercial ways. And they have really improved our lives and our quality of lives, simply because of the innovations that we've made. So I keep talking about these innovations and developing new technology. So we've done a lot in the last 50 years to learn more about technology and to grow with electronics, with robotics, biology, chemistry, physics, and astronomy. There have been leaps and bounds. So one of the things that we've actually been working on, so it's technically a new, but also improving current technology, is being able to grow food. There's been work done to grow space lettuce, space spinach, and other vegetables on the International Space Station. And they've done this a few times, and they get to eat the food that they make. That is something that we never could have thought about before if we didn't have the current technologies that we have. Being able to grow food, be able to study microgravity's impact on ourselves and on certain things like growth of plants, or the flow of fluid. It's really been the perfect way to conduct physics experiments and engineering experiments, and being able to look at biology in a different way, because things may not necessarily work the same way that we've expected on Earth, because this is all we've known. But if there is life out there, it could be operating in a different way. Also, by working on the technology that we've had, we've been able to try doing solar studies. So being able to really learn more about our star, and to learn its pattern of activity and laziness. Learning that based off of different light spectra, it actually glows green, which is really cool to know about. But also just being able to learn more about biology and astronomy because of the technologies that we've developed, and because of the development of technology in science. We've also had improving fiber optics, which gets us better phone calls, internet, because now those are going through the ground rather than having to jump through the atmosphere. We've been working on electronics and developing things like PN circuits, which make it easier. PN junctions, which allow us to have things like solar cells and solar panels, and have computers and phones, like computers that keep getting smaller and smaller, but being way more efficient. So things like these are so important because they don't just have applications in science. They can apply to everything, everyday things. And what's even more awesome, is that this isn't a male-driven subject. We're seeing a lot more women joining, and they're bringing so much to the table. And we're seeing women leading in these really cool fields that before we weren't even able to be in because we thought we wouldn't be smart enough for that. No way. As you see here, there on the on the left, this is a pre-assembly robotics demonstration for something that will be assembled in space. So they're trying to figure out that everything is working right. To the top right is a new fiber optic cable that is being worked on with nanotubes at NASA. And then at the bottom is some 3D printing that they've been using in technology to see if it'd be more cost efficient and sustainable to keep developing that technology and make it easier to build things like rockets or fuel efficiency, or working with robotics. So there are so many applications of technology, and we need people who are willing to go think outside the box and be creative. Science isn't just about logic and numbers and all of that. You have to be creative with it, because otherwise you're going to lock yourself into a box and not really think in other ways that could be more efficient or more correct. And we call these scientific revolutions, and so they are very important. So one day, the probability of like some of you being able to do these kinds of jobs are very high, and you guys are going to be, well, you girls are going to be the next generation of scientists that will take us somewhere, and somewhere great. So if you have any questions about any of these technologies, I'd be happy to answer them. Just know that anything is possible if you put your mind to it, and don't let anybody tell you otherwise, that you can't do something like this. Engineering is also a woman's field. So, and also with that, I guess I could do a quick review of what we've talked about for the last month, since this is our last class.
And maybe we can just remind folks before you do that, while Hannah's talking, now's the time to ask your questions. This is our very last class on astronomy for you guys, and we would love for you to put questions in the Facebook page on the Girl Scouts of the Green and White Mountains, and just use your first name and your location. And Hannah will do a little wrap up first, and then if we get some good questions, we'll definitely be answering them.
And I thought I'd also read this. I forgot I had this. Technology is what keeps pushing us forward. So this is a quote from NASA's administrator, Charles Bolden. Because of the 1,600 new technologies a year that we develop, and the thousands of products, services, and processes that we help businesses transfer into the market for job creation and economic growth, the state of our NASA is strong. So the state of our being and our society actually does kind of flow simultaneously with technologies that have been developed. And so it is something important for us to know is that technology is what drives us. And so it's important that we be able to think about technology in a sustainable way, but also a way that is really interesting, and know that we can believe in ourselves to come up with something new. So for week 1, let me just close this. So for week 1, we talked about the solar system. And we talked about how the solar system is made up of planets, moons, asteroids, comets, not comets, and dust that orbit around the sun. And you learned how to use a model to describe this whole system and how it's spread out. And you learned how to make a scale model of this in different ways, and to think about where the Earth is and how big things are in your mind in comparison to how they really are, and learning that it may be different than what you really thought. For week 2, we did something a little bit different. We talked about space and time. So how an orbit can make up a year, and the distance between a planet or an object and its star or whatever it's orbiting dictates how long that year is. And so the further away you are, typically the longer your year is, but that doesn't necessarily mean that a day is just as long or shorter. So that has to do with how fast something is orbiting on its axis. So in this class, you were able to describe what a planet's motion around the sun is called, or an orbit, and that one revolution along the orbital path is what creates a year. And the year is determined by that length of time. So one revolution equals one complete orbit, and that is a year. 1 year on each planet, or one planet, it will be different from another year unless they're directly close to each other, which cannot happen because then they would collide with each other. And so you had your lesson vocabulary, and then you learned your birthday or how old you were on each planet in the solar system, which was pretty dope, I'd have to say. And then last week we talked about constellations, which I talked about briefly in the beginning of this class. So you just learned about how constellations are formed by stars that are nowhere near each other, and the shapes that they form are due to our perception of these images. And so you now should be able to recognize and be able to describe some of these constellations, and also be able to talk about some of the significant stars that are in those constellations. And so there were some tips and highlights for each of these. And then for your assignment, you either had to do a, oh, maybe I accidentally read the brownies there thing. You had to do a PowerPoint presentation and a constellation scavenger hunt. So yeah, did I read them the wrong thing?
Well, I think you read them the right one. And I think, we can end there. That was a really nice summary, Hannah. And of course, we've been really grateful to have you all with us for the 4 sessions of this class for juniors that we had this past month. If you're looking for our past classes, or even this one, or the handouts that Hannah has mentioned that go with each class that you should also take a look at doing, you can find them all on the Facebook page for the Girl Scouts of the Green and White Mountains, all 4 classes and all 4 handouts. You can also find them at fairbanksmuseum.org on our virtual learning. So just a warm thank you to Hannah for all of her effort and all of her work on all these classes. And a warm thank you to the Girl Scouts of the Green and White Mountains for partnering with our little museum on this series as well. And thank you to all of you for being here. So I hope you have a wonderful Friday.